Okay, so hello everyone. Today I want to talk to you about serverless on AWS and with also a little bit of Python and how it can help you. So first, few words about me. I'm currently a backend engineer at Brainy. I work mostly with Go, but also with Python in machine learning infrastructure team. So quite a lot of wide range of profession, and also as a hobby, I brew my own beer. So here is contact for me. If you want to comment, feel free, and I always welcome feedback, and I want to be better. So go ahead and message me. I'll use the inventory app. So agenda for today. First, I'm gonna tell you what even is serverless, then when it's a good idea to really go serverless, then specific features and services on AWS, and then how can we use tools to help us work with that, and prepare some basic workflow to get reproducible results. And then we'll have time for questions. So when you are right now with, I really like this 4 steps of learning. First, you don't know that you don't know because you have no idea that something exists. And I was at that place with serverless like a year ago, maybe. Then you know that you have to learn something, and then finally you know those things. And at the very end, you do these things automatically, and it is just so obvious to you. So I hope after this presentation, you're not gonna be here, but at least here. And my goal is also to put a lot of doubt, to not jump you into the hype-driven development, because it's always a mess, and I've seen it too many times. So what even is serverless? Like, we have a data center, and suddenly we do not have. No, it's not that. It's repeated always at every serverless talk. It just means we do not have to worry about servers. I really like the Mike Roberts idea. Sorry. He wrote a blog post on Martin Fowler blog about serverless. I highly encourage you to read it. There's a link. My presentation will be shared with you, so you can go there and also watch the talk I've got it from. So his definition comes from 5 points. First, there's no management of server hosts or processes. It's pretty obvious. We do not have to worry about machines. Then, self-autoscales and auto-provision based on load. This is very important for the serverless features, and I think this is what gives it the best power, because we do not have to invest a lot in creating autoscaling scripts. It will be taken care of. Next thing, costs are based on precise usage. This is another very important thing, because if we use some service for a few minutes a day, why should we pay for it to run on some VPS for 24/7 or some bare metal server? And performance capabilities are defined in terms other than host size or count. And this can be very problematic, because like with DynamoDB, as I will show you later, it can mean that you won't be sure how much money you will actually spend. Probably it will be not much, but it's sometimes really hard to count. And also implicit high availability. We do not have to have 3 separate machines to have HA, but it will be also taken care of. But also what I find more important, and I also get this from another talk, but unfortunately I don't remember the name, the serverless is more the gradient. It's gradient or spectrum, because on the very most server thing you can have are bare metal servers. You can go into the data center, you can touch them, you can connect to them, you can destroy them. And the least possible, the most serverless things you, on the other hand, have are Lambda functions, Lambdas, which is function as a service. But there are things in between, like managed container services, like Kubernetes, like Elastic Beanstalk, and I don't think that it hits either of those definitions, so we should put those in between. And in general, the least management you need to have, the bigger is your convenience, the least DevOps you need to hire. But on the other hand, the less control you have. and it's a very important thing. Probably if you want to go full enterprise, you want to have as many control as you want. But on the other hand, if you look at Netflix, they use AWS with infrastructure as a service. They try to build their own data center, but, well, they failed. So why even go serverless? I found this very interesting blog post where the company wanted to create a web shop, but they also wanted to go into this Dragon's Den show. I don't remember a Polish name, but when basically investors are sitting and then people are coming and pitching the idea, hey, I've got this great idea for a company. Will you give me money to do it? And the problem is that this is how traffic looks like during the show. Basically, it goes from 0 to few hundred thousand users on your website instantly. And to be able to handle those kind of traffic normally, you would have to put a lot of money into the servers. But then if you would have thousands of instances, you would have to pay for them upfront, you will have to install them, and also there are a lot of problems that comes with that. So here's also another link. Guys built actually completely serverless shop with also Stripe as a backend, Stripe plus Lambda, and it survived this traffic. And it's open sourced on GitHub, so you can clone it. So concrete features on AWS. I will go through a few of them, not all, because there is too much of them. So first, I don't know how many of you are into machine learning or creating models. Just raise your hands. Oh, at least one person, great. So basically the problem is when you want to create complex models, it takes a lot of time to train them. And I have a GPU in my laptop, but sometimes I hit the limit of performance. It takes just too much time to even train for one epoch, and we want to have it as fast as possible to quickly iterate on the results and tune our hyperparameters. So we have one option. Go and buy a nice GPU, which costs like $1,000 or a new car. But there is another solution. We can go to AWS. There is SageMaker there, which basically just enables us to click and create Jupyter notebook on the cloud. Well, we have to put how big we want our instance to be, like with how big GPU, how many GPUs, and how much memory. But it's very easy, and basically after you click create notebook instance, then you will be instantly taken into Jupyter notebook. And it's fairly cheap, I would say, because after playing for a few hours, for a few days there, I paid less than $10, I think. So it's really worth a shot. It's normal Jupyter notebook with Conda, so we have a lot of libraries installed. And it also, but these are things I haven't tried, it enables you to host the models and perform A/B tests. But the reason I haven't tried them is because you have to run the Docker containers 24/7. So that's not serverless things. And if you do not have to perform constant model estimations, it will like just burn the money. But about the alternatives, there is pretty good alternative from Google. It's called Google Colab, which I think the biggest advantages of that is free. And you can cooperate like on Google Docs and like even run your code on GPU for free. There's sometimes queue because other people are using it, but I think the advantage is amazing. And also there's Data Lab, which is very similar to SageMaker notebooks, but you have to create the instances for you, and it's not free. So the next thing, like pretty mature project. So it was launched, I think, 4 years ago, Lambdas. I think they became fairly known in the Python community. And this is the least possible management, like I said. It won't get easier for you. You still have to declare basically 3 parameters. How many concurrent lambdas you can run, given lambdas, how much memory you will give to them, and what's going to be the timeout. So, and based on these 3 things, mostly on how long is one given Lambda going to take and how much RAM you're going to give them, you're going to get billed. And this is, I would say, also pretty cheap, because for first 1 million is free, and then you also get billed by 1 million invocations. And there are alternatives on Azure and Google Cloud. There are Lambda also cloud functions, and there are also Cloudflare workers. So if you want something alternative, it's good to know that they exist. Yeah, so all about Lambdas. And about the use case, I found that I wanted to create a Slack bot. The idea was to, after you type GIF something, just download random GIF from the Reddit, from the given subreddit, and reply to the Slack. And Lambdas were pretty amazing, because otherwise I would have to just run the VPS 24/7 and pay even like $5, I think is the cheapest, for it for a month. And why? I mean, I won't hit 1 million invocations on that, so I basically can run it for free, or very for few cents. Okay, let's go further. There's also AWS Cognito, which is user management as a service. This is pretty confusing name, I would say. Basically, AWS takes care of users' registration, remembering forgotten passwords. You can add groups to users. You can do all kinds of authorization, and they have it on their side. There's one problem, though. You can't export users. You can import them, but AWS does not provide a tool to export. So once you go Cognito, it's hard to go back. And there is a way to do that, basically two, what I know. One, there is a tool written, so you can just export users, but that's a third party, and there's possibility that it won't work at some point in time. But also you can hook Lambda functions, so each time the user registers, it will be saved, its data will be saved to some table on your end. Then it will be very easy to export out of Cognito. And this is basically the default view. I just click, hey, create user pool for me, and this is what they've done. Like, I can sign in, I can sign up. They also take care of password policy. You can put the requirements, how long, how many letters, and so on. Okay, I'm running much faster than I tried, but so there's also AWS AppSync. How many of you know GraphQL? Just okay. So basically, the GraphQL is a library or tool for Facebook. It's for creating APIs. It's running through HTTP or sometimes WebSockets, but it gives us slightly different approach than classical REST APIs. For example, in classical REST, if we would have two endpoints, first, let's talk about Twitter, for example. The first that gives us a list of IDs of the newest tweets, and the second that for a given ID gives us the content of the tweet, then if we would just want to show the list with content of the newest tweets as a client, first we would have to call an API and download the IDs, then the second call and download the tweets itself. And AppSync and the GraphQL have this idea of nodes, and like it says, graphs. I mean, if you don't even want to use AppSync, just go ahead and read, because the idea is pretty awesome. And then it will, on the backend side, just call this to endpoint, merge this, and send to the client. And also what it gives us, if the client will only get those data it wants. So it won't put additional overhead on our end. But also have one big disadvantage, because sometimes you can have nested nodes in a graph. So for example, for a tweet, we can have user, and then for a user, we can have his or her tweets, and then for these tweets, we can also have a user. And if we put those nodes inside and inside and inside, so many nested nodes, then our resources can be like exhausted pretty fast, and we'll pay tremendous amount of money, and we can DDoS ourselves. There are many ways to protect yourself from that, but like since GraphQL is still pretty new thing, it's hard to do that. And what the AppSync gives you, it maps GraphQL nodes straight to the DynamoDB entities, to HTTP endpoints, or to even Lambdas, or to Elasticsearch. And you can exhaust that basically without writing any code itself. You can create a CRUD application. And also what is pretty powerful, it's the language behind the mapping. You map the requests from the, you can see that. You map the request, and then you map the response from the HTTP to the GraphQL node. And you use the Apache VTL language for that. It's the template language. But what you can even do, you can check if given user, because if you authenticate through Cognito, you can check if this request was made by the owner of the tweet, so you can check whether to allow the user to edit or delete it. Or you can check user groups. If the user is an admin, also give him or her the permissions. But there's a pretty big problem there that if you do it that way, you will end up with your business logic inside the template language things. So I would say it's good for starters if you want to create something, but I'm not so sure that it would be a good idea for enterprise application. And also another problem is that if you use that inside the AWS, you go to the website, you will get the code completion. You can see what you have in variables. But I do not found anything so far, maybe it's time to write it, to give you the code completion inside any kind of IDE. You can have plugin for Apache VTL, but still it won't give you this complex variable when you have, for example, context.user.id to give user ID. Okay, so DynamoDB. It's a database or backend as a service from AWS. It's key value database. It's pretty easy to use. Basically, you put documents, you take documents out. There's no joins or anything. And it scales by using this write or read capacity units. You can calculate how many potentially you want them, but the problem is it do not exactly work that way. At least it wasn't at least a year ago. And why is that a problem? Because it's undocumented, and you don't know how AWS works behind the scenes. This is what I said earlier. You do not have full control over what are you paying for. So if you have a lot of data, it will be split through multiple nodes. And then each write or read capacity, like you have, will be distributed evenly. So if you have 10 nodes and provide 100, let's assume, read capacity, on even node, you will have only 10. And then if you choose your key poorly, and you will have hotkeys, then one node will need to scale up. But since this one node needs to scale up, all need to scale up. So it's really important to choose the right key. And this blog post here explains the situation. The first blog post they wrote, it was, hey, DynamoDB is awesome. And then after a few months, hey, don't use DynamoDB. But no, the title was, you probably shouldn't use. And that was the reason I wanted to use it in one project, but I was so discouraged that I postponed it. And right now, I kind of regret it, because I think in small project, it was a good idea to try it. Also, it will auto-scale. You can set the limit, so you probably won't have to worry about overcharging. But the best and the most awesome thing so far is that this service all services that I've spoken of can connect, and can connect in a very, very, very awesome way. Because first, you let your user get the token, JW token, through Cognito. And then AWS AppSync, you can configure AppSync to only pass through the authenticated users. You won't have to worry about any kind of limiting on your end. And then AppSync can use Elasticsearch provided by AWS. It can use directly Lambdas or Dynamo, or through Lambdas you can call anything you want, basically. Or even if lambdas are too limiting, you can put any kind of HTTP endpoint and also map it. And this is the most powerful thing that comes from serverless on AWS. About lambdas, I forgot one thing about the languages you can use there. Of course, you can use Python. You can use JavaScript, I think Java, and definitely Go. And here is pretty funny thing because Go is much faster than Python. And that's like pretty obvious, but not on Lambda. When I was running the tests, like it was just hello world for starters, but the overhead of Lambda itself and network was so big that there was no difference, whether it's Python or Go. And currently, I think Node.js is the fastest language on Lambda, but still, it's always worth a check because you don't want to tangle yourself in lower language if you can write something in Python. Okay, so how to work with that? Because everything I've told you so far and shown was straight from AWS UI. And this is like not probably the best idea how to use them, because if you would want to reproduce your results, like what are you gonna do? Screen cap your all work and then watch it later? No, that doesn't make any sense. So there are two projects worth looking at. So first is Chalice. It's from AWS. It's serverless framework. And I highly recommend it for starting. It's pretty mature project. It has like 5,000 stars. I've heard about it 2 years ago, so they had the time. But there is a problem with that. Then all the endpoints you're going to have in your applications are going to put into one Lambda and resolve it there. So the Lambdas have also concurrency limit. They have a cap on AWS. Baseline, what you get when you register is 1,000. So instead of having 1,000 concurrent requests per endpoint, you will have 1,000 concurrent requests per API. And that's not so good. You want to have with Lambdas as basically very small functions. Single Lambda should be as small as possible, so it's better to have separate endpoints in separate functions. And also, since Lambdas can hook onto different things, like I said about Cognito, they can also be hooked on to SQS topics, some even on Dynamo. At least when I checked last time with Chalice, you cannot you have to have at least one HTTP endpoint. And that's also the problem because you don't always need that. But the awesome thing is that this is everything you need for starters. This is the simplest hello world, and your code will be available to anyone in the world. And that's the amazing thing. And I really like the feeling when you just type Chalice or serverless deploy, and it is instantly in the cloud, and you can instantly show it to somebody. This is very, very nice feeling. But then, when you go and Chalice is not enough, there is also a serverless project. And they picked the worst possible name, I think, because every time you Google serverless AWS function, then you will get Lambda instead of that documentation. So this is pretty bad. Finally, I don't know how, but I somewhat managed to look for that. I just type in serverless framework, I think. It's a much bigger project than Chalice. It's third party. And the idea behind the project was to make your code base cloud agnostic. So once you declare all your functions and your configuration file, you should be able to deploy it to Azure, AWS, Google Cloud, IBM Cloud, and anything, any new provider they add. So you won't be vendor locked. And that's a very nice idea. But if you want to use AppSync, since they have basically no other alternative on other clouds, you will be stick to AWS, but you still can declare all those resources in one file. And this is very powerful because you have now version control over your stuff, and you also don't have to worry about the AWS CloudFormation file, which is pretty nasty, and serverless takes care of that for you. And I started a project that would work as an example, because a lot of examples right now, for example, use straightforward, you have to click through and create AWS Cognito user group, and then just paste into the YML file, into the configuration file, the ARN ID. And this is not what I was looking for. I was looking for that if you only type serverless deploy with the new project, it will be whole and ready in the cloud. But I'm honestly pretty far away from that because documentation is not great, and you have to learn by yourself and sometimes reading the code. Serverless is mostly written in Node.js, so that can also be the problem. And another thing, this is too small, sorry. Another thing that you want, because I work in an environment in day-to-day where we have continuous integration. Everything that's merged to master, it's automatically deployed. So I also wanted to replicate this behavior because I find that it's very, very useful and it's easy to use. And it's much easier to deploy. So we can use AWS code build for that. Basically, each time something is merged into your, for me in that case, GitHub account, the AWS will execute the tests and will execute the serverless deploy to put your resources on AWS. The good thing is that if you are running it that way, you won't have to worry about your keys leaking out outside AWS, because you have this configured by policies. In code build, you can even hook up some performance tests. I haven't done it yet because it's third party and it is paid. I would assume we would have to pay pretty much money for it. But yeah, that's also an option. So right now we know that we can have continuous integration configured, but how to work with multiple developers with that? Because like I showed earlier, it's just one command to execute. It's chalice or serverless deploy. So the best idea I found so far, which is still pretty bad, is for each developer to have their own AWS account, like totally independent. It will be their own sandbox. And then one master account to actually execute this code build and run it to production or staging before that. And I know it's bad because it would be much easier to have them in organization and put the budget limits on that. But so far, like, nothing has come to my mind, and I think even serverless recommends something like that to each developer have their own account. And this is also not the best idea because if you like screw something up very, very much, you can overcharge your card. And yeah, I think at first I was very worried about that, but then when I haven't seen any big bills from AWS, now I'm less worried, which is also probably not the best thing. So here comes the Python part. Because, like I said, serverless is written in Node.js. And we have also utils there to test. For example, to register users, we only can call one function. And we will have registered user, then we have API key. But like writing tests in Node.js is not what we want. So here comes Python, and here comes Boto. Because Boto is SDK for AWS. And through this SDK, we can create users, we can authenticate them, we can do basically anything. And then we can run our test. For example, this is very simple test. I log in, then I want to call my Lambda, which is behind authenticator. I will get 401 code, and then when I call it with the authorization token, I should get 200. And this is the simplest test I could think of with usage of Boto. And it worked, it passed as it should. Yeah, this is the best thing that comes from Python on AWS. So, key takeaways. Go and play, because, like I said, it's awesome to see your code live in a few seconds, like with Chalice. Use Chalice serverless to have version control and any kind of control on your own. But I recommend starting with Chalice because it's much simpler, and serverless adds a little overhead, and it also requires to give you to it like omnipotentious power over your AWS account, which is also not the best possible thing. But they say that because they don't know how many features they will include in the future, they want to have it that way. And the last most important thing, do not vendor lock yourself ever. Because if you put in your applications the URL straight to Lambda, and at some point in time you will want to go away there from that, you can't. And there was a case about some startup that was doing IoT, home automation, and they used Firebase as a backend, which is also serverless. So at one point in time, the backend policy, how the Firebase was charging them, changed. It was small undocumented change because they started charging for the failed requests through HTTPS. And since it was home automation, they didn't use their SDK, so they have a lot of these failed requests. And suddenly their bill went up, like few thousand times, from a few dollars to a few $1,000s. And nothing was showing in the console. They couldn't debug it, so finally they reached out to Firebase and they said, hey, it's because we changed that, and basically we can't do anything about it. And they updated what they could with the final devices. But since it was on embedded, they couldn't update everything. And that's the problem. The same is with even more common mobile apps. There is also always small percentage of users that won't update. And even if you have the smallest possible gateway, which is proxy behind domain, so your Lambda will be called instead of directly on AWS through your domain, I think that can be enough, because at worst possible scenario, you will switch that domain, and you won't be built. So that's all. It went, as always, much faster than I thought it will be. And now, are there any questions? Yeah.
1, 2. Okay, thank you for your presentation. It was very interesting. The most problematic thing when I think about using something like Lambda and something like other services from AWS is integration testing. So assuming that you have a Lambda with a API gateway or other software, and you want to do integration testing because you are doing continuous delivery, how do you try to mock the AWS stuff? Are you just recording how the requests are coming, or is there like a ready-to-use mock for this?
Okay, so that's thanks, because I forgot about one thing about testing. You can use Lambdas on your machine, and you can test them internally. Both Chalice and serverless provide that. But with the other services, you can't. With AppSync, also with Dynamo, you can run it locally. There is a Docker, there are libraries for that. But AppSync, there's one, but I couldn't manage to get it up. It's very small and unpopular on GitHub. And with Cognito, basically there's nothing, because it's too complicated, I think. And like I said, Boto is the answer. Like you can create users there, you can do what you want. And with the full integration tests, I think you can just, you don't have to mock anything if you want. And that's honestly, that's one of the disadvantages, because you have to deploy it to the AWS, wait for it until it deploys, and then only run tests. And this is the slowest part of it. And until we have completely offline usage, completely offline, complete environment, there won't be like full enterprise usage, because it just takes too much time to test them.
Okay, thanks. That explains how you test how your app is reaching to AWS resources. How about the use case where the AWS resources is reaching to your app? Like a AWS API server is reaching to your Lambda and that interconnection adapter?
Basically, when I think about integration tests, for example, HTTP call, because there's also the API gateway in between, and you're asking about that part. When I think about integration tests, I don't care what's in the middle. I care about the result itself. So the assumption is that if my tests are working, it means that this thing in the middle is working, which is pretty broad assumption, but still I can't think of nothing better. And like I also shown, the more abstraction you have, the less control you have. Any other?
Okay, so I have one more question. Have you heard about the Zappa, or do you have any experience with that?
Zappa?
Yeah.
No, never heard of it. What's that?
That's a library to run your SGI apps serverless. So you can even put the Django on the Lambda.
Okay, this is nice.
So it sounds like a crazy idea, but I just wonder if you have any experience with that.
Honestly, I think it may sound strange, but I have no experience with WSGI. Like when I was doing production, it was always Async or Tornado. And other than that, when I was running my apps, it was Lambda. So no experience with WSGI, so I never looked for that. And yeah, that's all. I will look into that. But.
Do we have any other questions?
Okay, I'm curious about pricing. Is it possible to use like spot prices, like in case of EC2?
Basically, there are no about to which because the only place where we are creating the machine was on SageMaker, and it's priced somewhat, I think, differently than the, or maybe even via normal price. But not the reservation, but you will have to pay. But on the other places, we do not have any machine. We do not have anything beneath that. So there is no spot pricing. You only pay for the invocation of Lambda or through output on Dynamo. There is no kind of list auction.
Another question is about invocation, because
Yeah.
you said you pay for invocation. So if I invoke one function, it can run forever?
No, you can set timeouts, and there is also some, I think, 1 minute timeout limit for Lambda. But you pay for invocation, and that's how they pronounce it, how they advertise it. But it's actually times of invocation multiplied by every 100 milliseconds of invocation, and then it's multiplied by memory you use. So it's invocations times something. And also with the Lambdas, you want to have it as small as possible. You work with like data streams with very little pieces. I mean, there's one use case when the guys done, I've heard about that, when they've done a lot of work on Lambda. Finally, they switched to AWS Batch, which is meant for larger jobs. But the idea was to have app completely separated. Basically, Lambda picked up the encryption key, like decrypted the data in DB and pulled it, because they were working with few hedge funds, and they wanted it to have as big separation as it can be. And that's the only use case I've heard about working with a lot of data in Lambda.
One more question about auto-scaling. Can it be used to throttle requests?
In which service? Because in Lambda, you can use it to throttle requests. You can use how many will be executed at one point. But with Dynamo, I don't know how it will behave if it's overloaded.
So it can be used to prevent DDoS attacks?
I think yes. With Lambda also, but I would say that probably if I would be creating an app, I would still put Cloudflare in front of everything, just to be sure, just in case. Thanks for the questions.
Okay. Do we have any other questions?
No. So we can still talk at open space, and feel free to grab me. I really love to talk about programming. So.
Okay. Thank you for your presentation.
Thanks.